So hello, good morning. So today we are going to discuss the trapezoidal method to find the integral of a function. Now consider we have a function y is equal to f of x. Y is equal to f of x. So we want to find the integral of this function between x is equal to a and x is equal to b. So that is we just want to find integral a to b f of x dx. So this is what we want to find. So this can be written as y is equal to f of x. We can write it as y integral a to b y dx. Okay. So our aim is to find this value of this integral, and we are making use of this trapezoidal method. Now, suppose we can draw a graph between y and f of x. So this is y and x, or f of x and versus x. So on this axis we have y is equal to f of x, okay, and this x is this, and we want to find the integral between x is equal to a and x is equal to b. At x is equal, this is the point x is equal to a, and the value of the function at the x is equal to a is this. Now the value of the function at x is equal to b is this. X is equal to b. The value of the function is this. This is the point x is equal to b. Now in between, if we give different values of x, we will get different values for y also here in between this x is equal to a and x is equal to b. Now we can divide the interval from a to b, x is equal to a to x is equal to b, to n intervals. So n small and small intervals. So let us take a small value, say h. First of all, the initial value, we want to find the integral between x is equal to a and x is equal to b. At x is equal to a, when x is equal to a, say y is equal to y0, say, or y is equal to f of x. You substitute the value of x is equal to a in the function f of x, that is f of a is equal to y0. So that means at yx is equal to a, this height is y0. Y0 is this height. Now you just give x is equal to a plus h. H is a small increment we are giving to the value of x. Now the value of the function is f of a plus h. So you can take it as y1. So what will be y1? If this is a plus h, next value of x is a plus h, so this height will be a plus h. So this height will be f of a plus h, then you can take it as y1. Similarly, to find the value of x, f of a plus 2h, give x is equal to a plus 2h, take the next point, and that is a plus 2h. Give a small increment h in x. Again, that the increment we are giving is h. So we find the value of the function at a first, find the value of the function at a plus h, then find the value of the function at a plus 2h, etc. So this is f of a plus 2h. This you can take it as y2. In a similar way, you find the value of the function at all such points. Okay. Now actually the function is like this. So we got the values of the function at different points like this at equal intervals of in x. Now we can construct small trapeziums. What is the actually the integral of integral of f of x dx between a to b. It is integral simply y dx between a to b. Y is actually this height. Now if the increment dx is, say this is dx, what is y into dx? If y is a height like this and dx is a small increment like this, y into dx simply gives the area of this area. Now y into dx simply gives integral y dx between a to b simply gives the area under the curve and the x-axis between x is equal to a and x is equal to b. Now to find the integral between these two limits simply means we have to find the area under the graph and the x-axis between x is equal to a and x is equal to b. We want to find this area only. So that will give the value of this integral. For that, what we will do? So we have divided this area into a large number of trapeziums like this. Small. X is equal to a, the value is here. X is equal to a plus h, the value is here. So you draw a line like this. So what is the shape of this line? Line is almost like this. Area is like this. The shape is like this. This point. Now we can approximately take it as you can join these 2 points with a straight line. So some part will be missing. So anyway, don't bother about it. So if you reduce the length, this distance, if you reduce the increment in x, this error will be minimum. So we can consider a trapezium like this. So this side is having length y0 and this side is having length y1. Now if this a and a plus h are very close, this y0 will be almost equal to y1. So we can almost consider it as a rectangle. So if you take this, so if you take a small portion like this, okay, h is very small. So almost these are same. So we can take this average height as y0 plus y1 by 2. Then multiply with this into h. So this will give the approximate area of this portion. Now what about the approximate area of the second trapezium? The second trapezium is having an approximate area. This is plus. This length is y1 and this length is say y2. Again this length is h. So approximate length is what? So approximate area is what? y1 plus y2 by 2 into h. Similarly for the third trapezium, okay, this is y1 and this is y2, okay, this is y3. So for this portion we can write y2 plus y3 by 2 into h plus etc. like this. So what will be the area of the last trapezium? Area of the last trapezium will be plus, this is yn, you can write, this is, then it will be yn minus 1, yn minus 1 plus yn all divided by 2 into h. So this will give the area under this graph between x-axis and between x is equal to a and x is equal to b. So we can expand this. This is y0 into h by 2. First term is, you can write in all these terms there is a y h by 2. This is h, this is divided by 2, here divided by 2 and it's multiplied by h. So h by 2 we can take outside. So what is this? y0 plus y1, okay, plus for the second term h by 2 we have taken outside. This is y1 plus y2. For the third term, h by 2 we have taken outside. This is y2 plus y3 plus etc. plus, okay. So this is equal to h by 2 into, you can see that there is a y0 here, y1 plus y1 again, y2 plus y2 again. So you will see y3 plus y3 again, etc. So last term will be what? Yn minus 1 plus yn. Okay. So you will get y0 plus, this is y1 plus y1, 2y1, y2 plus y2, 2y2, y3 plus y3, 3y3, like this. So 2 into y1 plus y2 plus y3 plus etc. plus, it will go up to yn minus 1. So last term, this will be yn. So you will get the area of the trapezium like this. Area of this curve under area between the curve and the x-axis between the limits a and b, like this. Okay. So this will give the value of this integral. So this method is known as trapezoidal method. Okay. So let us see what is explained here. We can join the points on the graph of f of x as shown in the figure and form n trapeziums. N trapeziums. Here the area under the curve is in a small interval, can be approximated with the area of the corresponding trapezium as shown in the figure. The total area under the curve between x is equal to a and x is equal to b is approximately equal to the sum of the areas of all these trapezoids. We have y0 is equal to f of a, y1 is equal to f of a plus h is a small increment, and y2 is equal to f of a plus 2h, y3 is equal to a plus 3h, etc. and yn is equal to f of b. Then the approximate area of the first trapezoid is given by h by 2 into y0 plus y1 by 2. Similarly, the area of the next trapezoid is h by 2 into y1 plus y2. Therefore, the total area under the curve between x is equal to a and x is equal to b is given as a is equal to h by 2 into y0 plus y1 plus h into y1 plus y2 by 2 plus h into y2 plus y3 by 2, etc. plus h by 2 into yn minus 1 plus yn. Okay. This we have written as equal to h by 2 is taken outside, y0 plus y1 plus y1 plus y2 plus y2 plus y3, etc. So this can be h by 2 into y0 plus 2 into y1 plus y2 plus y3 plus etc. plus yn minus 1 plus yn. So this is that. So if we can find the value of the function, value of this function at x is equal to a first, then x is equal to a plus h, then x is equal to a plus 2h. Okay, we are finding the value of the function x is equal to a first, value of the function at x is equal to a plus h, so h is a small value, then again value of the function at x is equal to a plus 2h, etc. Finally find the value of the function at x is equal to b, that is equal to x by n. Then substitute the values in this equation. You will get the value of the integral. Okay. Now, so how can you do it? Suppose we have a function is f of x. So I am not taking any example. First of all, x is taken as a. We want to find the integral between x is equal to a and b, f of x dx. We want to find this value. First of all, substitute x is equal to a. Find the value of f of x at x is equal to a, that is f of a. You take it as y0. Then a plus h. Give a small increment in the value of x, that is x becomes a plus h. Find the value of f of a plus h, that is y1. Again, substitute the value of, give a small increment in the value of x again. Now the value of x became a plus 2h. Find the value of f of a plus 2h. This is f of a plus 2h. That value is taken as a2. Next, you take again give a small increment in the value of x, this f of a plus 3h, x is equal to a plus 3h, this you find the value of f of a plus 3h, you take it as y3, etc. Finally you find, substitute x is equal to b and find the value of f of b, you take it as yn and substitute in this particular equation. Substitute in the equation, that is integral that is equal to h by 2 into y0 plus yn plus 2 into y1 plus y2 plus etc. plus yn minus 1. Okay. So what will be the algorithm? So if we write a computer program, how can we proceed? So first of all, we have to define the function f of x. So we want to find the required lower limit a and the upper limit b. So we want to find to what limit, so we have to perform the integration. A is taken as the lower limit and b is taken as the upper limit. We have to provide that values of a and b. Now input the step size. So first of all, we are taking x is equal to a, and next steps we are taking x is equal to a plus h. So this is h is the small increment we are giving in the value of x. So that is called the step size. So we have to define what is the step size. If the step size, usually h can be taken as 0.1 or you can take 0.001 like this. So when you decrease the value of h, the step size is small, more number of steps, repeated iterations are needed. So for if you are not using a programming for calculating this integral, so you can sufficiently, it is good to take some values like the 0.1 etc. Or you can take more values. And if the step size is small, the more accurate will be our results. If the step size is high, the less accurate will be our result. Now initialize an array. You can define an array like this in Python. Initialize the integral, the initial value y0 ആയിട്ട് എടുക്കാം. Now while a less than or equal to b, so we have to perform this operation until the value of x is from a to b. So check whether a is less than or equal to b. If a is less than or equal to b, go to next step. What is next step? Compute f of a and store in the array y. Now then a is equal to a plus h. Give an increment in the value of a. A is equal to a plus h. Again check whether a is less than or equal to b. If a is less than or equal to b, compute f of a again. So that now this time it will be f of a plus h. Again store in the array y. This process continues until y is less than or equal to b. When a is greater than b, go to step 9. Find the sum of all the elements in y stored in Sx. Find the sum of the first and last elements in y. In the array, you find the sum of the first and last elements Sa and Sab. So compute the integral. What is the solution? Integral y is equal to h by 2 into first and last element, that is sum of the first and last element Sab plus. Next we have taken 2 into sum of the second element up to the n minus 1th element, but we have taken the summation of all the elements Sx. So Sx minus Sab will give that value. So this will be Sx minus Sab. Sum of all the elements minus sum of the first and last element. So this will give the value of this integral. So this is compute the integral h into Sab plus 2 into Sx minus Sab all divided by 2. Print integral. So this is the trapezoidal method to find. Now here, so if our interval we are taking or the step size we are taking is large, what will happen in this trapezoidal method? Suppose we take a step size h is which is very large. If you take a 1 point here and 1 point here, so the trapezoid will be like this. So you are taking the average value or somewhat like this. You may get some value like, you get an area only like this. So we are missing on this much part. This much part of the integral. So if the step size is very small, so if you are taking step sizes which are very small, very close step sizes, you will get more and more exact values. Okay, so this can be done only through programming. So otherwise it will take a lot of time to compute the integral using trapezoidal method. Okay, thank you.